The METUS Tech Show.
Welcome to the METUS Tech Show, a show for HVAC professionals by HVAC professionals.
The METUS Tech Show.
It's so busy.
So, Zack, you're from Connecticut, and I keep hearing that Connecticut is like wicked good pizza. So, enlighten me.
Yeah, like I was saying earlier, Connecticut isn't really known for much, but what we are known for is our pizza. Specifically, New Haven is pretty much the pizza capital of the world.
Not Chicago, New Haven.
I would have
Chicago
to, I would have to second that. I have to second that, Zach, because I really enjoy my trips up to Boston when I drive, because when I come back, I go through New Haven. I try to get a Sally's pizza, so that's probably the best. My second one is Frank Pepe. And he has a bunch of locations all over, I guess, into like New York City. And I just tried out on my last trip, Modern Pizza. Which was
I was going to say
right
Modern is probably my favorite.
Pretty good
Sally's
stuff.
Is right up there too, though.
Pretty good stuff. I don't know what they do with the sauce or the cheese or the dough, but it tastes pretty good.
You know, Gary, in a future episode, we're going to talk about, was it Scrapple in pork roll? Because
Scrapple.
You gave me some of
yeah.
that. So just in full disclosure, I question your authority when it comes to food now because of that. But so what makes New Haven pizza so special? Is it thin crust? Is it thick crust? Is it more like New York pizza, Chicago pizza?
Yeah.
I would say New York pizza is a riff on New Haven style pizza, but it's the thin crust. It's crunchy on the outside, a little soft and thin on the inside. Really good sauce, really good cheese.
What are your go-to toppings?
So I'm a little bit weird. This might be a little controversial, but I love olives. So my go-to is pepperoni and black olives.
Oh, I can do that.
There's nothing wrong with that.
I'll do olives. Yeah. I do olives, green and black. Yeah.
So there's only two things I don't like on pizza. One is anchovies. I'm sorry, just don't like them. And the other one that absolutely people who want this on their pizza really, I don't know, there's no punishment severe enough for putting pineapple on pizza. It's just awful.
I knew you were going to say
it's
that.
It's not pizza at that point.
It's not pizza. It's just gross. Anyway, Zack, tell us who you are and what you do, and we'll get into it.
Yeah. So I'm from the Northeast Business Unit here at METUS. Been with Mitsubishi going on 10 years now. Before that, I was in the industry doing a few other things for about 3 years before that. I'm a regional sales manager on the commercial side of our business. I primarily work with consulting engineers, architects, getting our systems laid out, specified, and designed on commercial projects.
All right. Gary, you're joining us once again, so just remind everyone who you are and what you do.
Gary Ozer, a technical instructor out of the brand new Florence, New Jersey Training Center, also out of the Manhattan Training Center. Born and raised in Philadelphia. I've been around 4+ years now.
And your claim to fame is you were in the Rocky movie, right?
I was not in the Rocky movie, but they filmed part of Rocky, supposed to be Rocky 2. Never made it into the movie, but I got to meet Sylvester Stallone and Tyra Shire, a couple other the actors that were in the movie. They were just hanging up on stage. So I was on the stage and sound crew, so we got to enjoy ourselves with all the filming people, the directors and everything. They're all set up, and it was kind of very interesting.
All right,
So
I've yet to see a Rocky movie. Anyway, Bryn, that's no joke. I've never seen a Rocky movie. I've seen bits and pieces, but never the whole movie.
Yeah, same here. My name is Brendan Raptor, instructor out of the Boston Training Center, and I don't have nearly as interesting of a life as Gary.
And I'm Paul Shavs, and today we're going to be talking about hybrid VRF, right? So let's start off first with Zack, a question for you. What is ASHRAE Standard 15 and 34, and how do they apply to our industry?
It's a great question. So ASHRAE 15 and ASHRAE 34, a lot of people typically say them at the same time, thinking they're the same thing, which they're not. ASHRAE 15 is the safety standard for the use of refrigerants. So it outlines when and where detection and mitigation systems are needed to monitor any refrigerant leaks. ASHRAE 34 classifies refrigerants into certain classes and then determines what their concentration limits are. So what is a refrigerant? What type of a refrigerant is it? What are we going to do if it leaks into the space?
So you said refrigerant concentration levels. We call it RCL. Elaborate a little more on that and what that means for us.
So RCL, refrigerant concentration limit, defined in ASHRAE 34, that really represents the highest concentration of a refrigerant that can leak into an occupied space while still meeting health and safety concerns. There's really three things that play into determining the RCL of a particular refrigerant. First one is going to be your oxygen deprivation limit, or your ODL, basically how much can leak into a space and make sure that the space isn't filled with refrigerant to cause harm to a person. The next one would be FCL, or flammable concentration limit. Basically, how flammable is that refrigerant? Can it cause harm to somebody in the space? And then ATEL, or the acute toxicity exposure limit. Basically, how toxic is that refrigerant?
So we are going through, as an industry, a refrigerant change. That's going to be a different episode coming down the road. Today, we're going to be talking about hybrid VRF, or HVRF. Let's talk about what is a VRF. I think there are some people out there that may not know what VRF is. It's variable refrigerant flow. So just give us a high-level view of what that means.
Take your standard 1-to-1 mini split system and pump it full of steroids. It's pretty much what a VRF system is. It lets you use one outdoor unit to connect, all the way up to 50 indoor units, as well as having heating and cooling at the same time. So simultaneous heating and cooling. You might also hear it referred to as heat recovery. It gives you flexibility of zoning a building out, pretty much all the flexibility of a 4-pipe chiller boiler system with just one outdoor unit and an indoor unit in every space.
All right, so in an R2 system, that's a refrigerant recovery unit. So instead of having a big rooftop unit and giant ducts, to do a whole floor, a whole section of a building, we got one outdoor unit, we got a branch box inside for the R2, and we got up to 50 indoor units spread out throughout the building, and they can run independently of each other.
Exactly. It gives you all the flexibility and zoning that you need in a space without ductworks, large chillers, large boilers, etc.
Zach, I just had a quick question about the RCL ASHRAE 34. Is that a new standard, or has that existed for a while?
That's been around for a while.
Okay. So, Zach, when it comes to ASHRAE 34 and the RCL, how does that affect our typical R2 system or even Y series?
Yeah. So we need to take into account what the total charge of a VRF system is. So that includes your as-built piping lengths, indoor units, virtually an as-built VRF system. Once we get that total refrigerant charge, we need to look at the smallest occupied space that refrigerant piping is running in. There's some calculations we can run. There's something called the minimum applied volume. So that's the smallest space that you can have refrigerant piping running in, and you assume that the entire charge of your VRF system can dump into that space. If that space is smaller than that minimum applied volume, then it isn't compliant with ASHRAE 34.
Okay, so that's for that whole system. So what about the case I have a room where I'm not conditioning it for that system or from that system, but the pipes run up above the ceiling? Is that considered as well?
It depends on if that space is classified as an occupied space. And this has always kind of been a little bit of contention over the past 10 years or so, is what is an occupied space? ASHRAE doesn't define that, I think, nearly as clearly as we may need it. Now, that may be changing coming with the upcoming refrigerant transition.
Okay. Yeah, like I said, that's a different show. The A2L transition's a different show, but we are going to have a new refrigerant pretty soon. And by the way, the new refrigerants, I think I'm just going to mention this as a sidebar. There's no propane in the new A2L refrigerants. People think there's no propane. So
I can't light my stove off of that? Jeez.
You can try. It's almost flammable.
But with the new refrigerants, the RCL is going to be much lower than what we're looking at now. We're going to have to be paying much closer attention to doing those calculations during VRF designs, and it's going to just cause a lot more work for a lot of people.
All right. And how is the HVRF system going to help us in that with the RCL?
That's the beauty of the HVRF system, is that there's no refrigerant piping running through occupied space. Your only refrigerant piping is going to be from your outdoor unit to your hybrid BC controller. Typically, that piping is not running through an occupied space. If it is, then you'll have to deal with that in those spaces. But from your HBC out to all of your indoor units, which would typically be an occupied space, it's all water piping. So you're not subjected to ASHRAE 15 or ASHRAE 34. you don't need to worry about doing any of those calculations.
So let's assume that there's a mechanical room, and that's where the HBC, the hybrid branch box controller, is. Wouldn't be considered an occupied space, a mechanical room, right?
Typically not.
All right. So the refrigerant never leaves a mechanical room.
That's correct.
All right. That's
well,
good
it goes up to the roof, but
right. I'm talking about once it's inside the building, it just goes from the outdoor unit to the HBC inside the mechanical room, and everything else after that is just water.
Now, Zach,
right.
as far as you know, when it comes to if we were going to use our HBC in a mechanical room, are there any guidelines or rules as it pertains to having refrigerant monitoring or anything in those mechanical rooms, or simply because it's an unoccupied space, they're okay to let it vent there in the case of a accident?
So the rules haven't been officially released yet, so I don't know if I can comment very intelligently on that. I would say it's safe to assume to err on the side of caution. In that mechanical room, it would make sense to have some leak detection, maybe some mitigation factors in there, venting, bringing in outside air, that sort of stuff. But until the rules are kind of officially released, can't really comment at this point.
Zach, the whole premise of our show is commenting on things intelligently or lack thereof intelligence. That's what we do here.
Yeah, I mean, I've just heard so much going around with all this change towards lower GWP refrigerant that we are kind of switching to A2Ls, and the result of that is having to make some changes. But a lot of it seems like it's still up in the air. So I have heard things about exhaust fans and refrigerant monitoring wherever that refrigerant exists. And then I've also heard as long as it's an unoccupied space. So I was just curious if you had any more insight than what I've heard. But I think this stuff is going to continue to develop up until we start shipping these out.
So basically, we don't know yet. All right. So that about does it as far as understanding the RCL and the VRF and the HVRF. I'd like to focus on the water side of things. Correct me if I'm wrong, but the refrigerant side of things is the same. I'm still going to use the same outdoor unit, the same R2 outdoor unit. I'm going to use an HBC instead of a BC, and I'm going to pipe the refrigerant from the outdoor to the BC, and that's it. Everything from then on is water, right?
That's correct.
In my indoor units, Gary, my indoor units are addressed and grouped, and everything's done the same way it is for a regular city multi-system. Is that correct?
Everything's the same from the outdoor unit, refrigerant piped into the HBC, and all the products of it,
and the MNet.
dressing, port assignments, daisy chaining, you name it, that's all the same.
Okay.
It's all the same as City Multi.
All right, so let's just focus on the water side of things from here on out. All right, so let's talk about the piping, the water piping. What am I allowed to use? What can't I use? What's the best thing to use?
There's two different piping that we're using. We could use copper with mechanical connections, ProPress. We say ProPress?
Well, we can say ProPress or a ProPress type thing. I think it's like Xerox and Kleenex.
Yeah. So that's one way you can do it. That's a nice, clean way of running your pipes is with the ProPress. The other is a multi-layered piping through Rahal. And what that multi-layer piping is, it's a pert plastic with an aluminum sandwiched in between another piece of the pert plastic, and that is to be used on the water side. So what's not approved or you cannot use at all is any kind of PVC piping, PEX piping.
What kind of pressures are we talking about?
We're looking at between 14 and 27, I believe, PSI.
So
it's just, and depending on atmosphere and where we're located at, what your pressure is coming in. So it's pretty much standardized water pressure of your building.
All right, so I can understand no PVC, but why no PEX?
The construction of it, and I believe also the rating of the temperature and the expansion of the pipe itself. So it's a thinner wall that's on that type of product. So the only approved is the Rahal at this time, and it's a very nice product. Once you see it and lay it out, it's a very sturdy piece of piping.
Mind if I comment a little bit on that?
Sure, absolutely. That's why you're here.
So the Rahal piping or the MLP PERT piping, whatever we want to call it, is a little bit more sturdier than PEX. In our system, you can see water temperatures anywhere from 40 to 140 degrees. PEX really isn't set up to work with those higher temperatures. That's why we're using that Rahal piping. The other thing I'd mention too is that the HVRF product is not a new product. It was developed for the UK market 7-8 years ago and was released 7-8 years ago. So it's kind of been tested overseas for quite a few years now. And they initially started to use a little bit PEX over there, and they found a lot of issues with it. The hangers, the support system for it, the expansion that goes on. And that's why we standardize on this Rahal piping.
So we had the benefit of having other countries use it first, figure out what worked and what didn't, and we're going to cheat and steal from them. I mean, information. I don't know if you call it cheating. I guess it's learning from their mistakes.
We took a shortcut. Let's say we took a shortcut to the right answer.
That was our R&D over there. That's the R&D department.
I like it when that happens.
I will say that I've got to actually install one of our indoor coils using that Rahal piping, and that stuff is sturdy. It kind of looks similar to like a frost-free PEX with the metal liner. It's similar to PEX A style when you secure it to fittings. It's got a little ring that pulls over like a barb fitting, but that stuff's not going anywhere. Once that's secured properly, I mean, it's on there good. I actually messed up and had to take it apart so I could reuse the fitting, and just getting that plastic slip ring off was a nightmare. So that stuff's not going anywhere once it's installed.
There is a process for removing it. It shouldn't be cut off or ripped apart.
Hold on. I do want to talk about the Rahal piping and the tool that's needed, but I want to go back to the copper for a second. You mentioned using some type of press tool with those special fittings.
Yes.
And it's water. So, I think ProPress is one of the most common ones out there. And I don't do a whole lot of plumbing anymore. So forgive me for those of you who do. There may be some other brands. We don't push or advocate one brand over any other. Use whatever tool you would normally use for water piping. But can we solder the water pipe?
Absolutely not.
No.
Cannot use solder. If you do have to connect any copper piping together, you would use a braze method. A braze with a flow of nitrogen, just like on a refrigerant pipe. And the reason why they don't want to have any kind of solder is that the flux residue, once it gets inside the piping, can cause damage to the pumps that are internally inside the HBCs.
Oh, wow.
So you want to really refrain from, and do not use it. Not refrain, but you cannot use any type of soldering devices on that. It has to be brazed if you need to braze any kind of connections.
In this day and age, a lot of jurisdictions, they require a hot permit. Some cities require a fireman be there with a fire extinguisher.
Yes.
So it's just a headache every time you got to light a torch these days anyway. So you're better off getting one of those press-on tool.
As we get into the installation of the HPC box and going to the indoor units, we have a ball valve. It's a Halefi ball valve, and the port that comes off of the HPC is 25 millimeters. So that's a metric. And how do we transition to whatever pipe we're using? This ball valve that connects on there with like a compression type fitting. And then once the ball valve on the other side, it will transition with a fitting or a tailpiece, you might want to call it. It would transition to the ProPress, or it would transition to a fitting to accept the Rahal piping.
Interesting. In that piping, let's talk about that tool, because you've used the tool, I've used it, Bryn's used it. Zach, have you used that tool yet? Well, I saw you hold up a piece there. We didn't mention that you guys are not in the studio. It's not a studio, it's a conference room. But both of you are where you are. You're in Connecticut and Jersey. You're not here. You're joining us remotely. So you did hold up a piece of that Rahal piping. It's pretty sturdy.
So when HVRF was first kind of released, we bought a hybrid BC controller on the sales side to bring out to our customers to show it off, explain it. And part of that too, we have some piping and some tools. So if you can imagine it, a bunch of sales guys got together, took apart the HBC, cut some pipe, put some fittings in, and we were able to figure it out.
Well, if you can figure it out,
if it's easy enough for a sales guy to do.
If a sales guy can do it, then anybody should be able to do it.
Well, if you want to come up and finish our install, feel free.
Well, they did put it back together, and then it leaked like a sieve. They did it all wrong, backwards. Anyway, so let's talk about that tool. Right? I know this is an audio show, not a visual show. And I know, Gary, we got some training planned. We got some videos planned for all this. But just give us a quick overview of the tool as best you can without any pictures.
The tool is in a kit. Kit has everything you need to install the Rahal piping. Comes with the manual. There's a manual expander. What that expander does, that will open up the end of the pipe to accept the brass fitting that gets inserted in there, like a barb fitting, basically. It's a very large barb type fitting. It fits in there. So to connect that over, you would slide a connector piece over the piping and then accept it into the brass fitting with the tool. So it's going to compress over the barb impressions that are on the brass fitting, and it locks it in. Once it's locked in, it's there. You cannot get that off.
Yeah, it doesn't go anywhere.
Yeah, we've tried.
I will say it's similar to flaring, right? So we got to put that securing ring on before we expand the pipe.
Yes.
Because if you forget, you're doing it all over.
No one forgets that.
Yeah.
I did once.
And it's just a regular PVC cutter, like one of those ratchet style PVC cutters.
It's a very strong PVC cutter. And I checked. I cut a piece with my own cutter that I have, very inexpensive one, and it cut it perfectly fine. But the one that comes with the kit is a very heavy duty type tool for cutting the Rahal. As I mentioned before about removing, cannot cut. Once it's pressed on there, you cannot use that sleeve again. You'd have to use a new sleeve. And the method to removing that is that you would have to get a heat gun, and you would have to heat it, not an open flame. You'd have to use a heat gun to take that sleeve off of there and pull the fitting out.
Right, so
you can reuse the fittings, but you can't reuse the sleeve.
And that's why you'd want to take it off. Just, hey, I made a mistake. The pipe's too short. I don't want to throw this fitting away. And all of those HVAC guys listening, when you hear heat gun, I know the natural instinct is I can use a torch, but don't use a torch.
I don't want to use a torch on that.
No, that's official heat gun.
Yeah.
Right.
Yeah. So anyhow, nice quality type of a heat gun, not a hair dryer, but I don't think that's going to cut it.
So you mentioned Kalefi. Is that what it was? Kalefi ball valve.
Kalefi.
That goes from metric to a standard. What other kind of accessories are we talking about? So we got the water line. So what kind of accessories are going on there?
So if you're coming off of the HPC, you're going to put ball valves on all equipment and all ports. This is going to transition. All the ports that are on there are the 25 millimeter. So you're going to have to transition down. And what's nice about that ball valve is that it fits on there very nicely onto the ports. Then you can transition to whatever sizes that you're gonna go to. So the ball valve will go onto the branch controller, the HBC. But also when you're coming off of there, depending on where the highest point is, you'll be able to put the air separator on the HBC coming off if the HBC is the highest point above all of the indoor units. So we'll get more about the air separator. The other component that you would install on the HBC is a drain valve. And the drain valve that comes on there, it's another Kalefi product. It's a T, and that T would go onto the fitting off the ball valve. Then you would have a drain, so you could use that for any type of draining or for pressurizing your pipe at that point.
And this is water that's being heated, so we must have an expansion tank somewhere.
Yes, the expansion tank. So they have a couple different methods of filling the system. There is a what we're calling a permanent fill line option. On that permanent fill line, you would have your city water, your supply water coming into this fill line, and that's going to have a isolation valve, going to have a double check valve. It's going to have a combination regulator with a pressure gauge, and then that assembly is your fill into your system. It's an option that they have on there, or you could fill the system with a system feeder tank. And either one of these methods, either the line fill option or the system feeder, that can get connected along with the expansion tank onto a wall bracket. So you'd have the wall bracket, you would have either the permanent line option, or you'd have the system feeder option to go on there. So there's a lot of different configurations to meet the needs of the installations.
So that's interesting, because I used to do a lot of boilers back in the day. Typically, you got the water line coming in, you got a backflow preventer. If it's a city water line, you got to put a backflow preventer. So if the fire department hooks up to a fire hydrant, they're not sucking that water back into the drinking supply. And you got a pressure reducing valve and a bunch of other things. You talk about air separator, because when there's water coming into a system, there's air. But this, the system feeder was new to me. Give us a little synopsis or a little lesson on how that works.
Once the system is filled, it's a closed system. Mm-hmm. It's not a steady flow. So once you fill the system, there's an isolation valve that gets closed, and it's a closed loop system at that point. So there's not going to be any kind of steady water going into your system.
Right. And when you do a boiler, you have the waters on pretty much all the time. But if you turn that water off, it takes years for enough air, because we're not pumping water. We're just moving it from one side of the circulator to another. Yep. It's not like a pump. So if you were to turn that water off, and I've seen this happen dozens of times, it takes several years before there's enough air and it becomes airbound where the water doesn't move. But the problem with leaving it on all the time is if there's a leak in the system, you have an open water pipe basically coming from the supply in the building, wherever it is. But with this system feeder, you fill it once, you shut it off, and you're done. So if there is a leak down the road, you're just losing the water that's in the system. It's not like having an open faucet pouring into the building.
The other thing with the system feeder, and correct me if I'm wrong, is this is also where we can put pre-treated water, or if we were going to glycolize the system, this is a good application for that system feeder.
If it's glycol, it needs to be added to the system. It can be done through the system feeder. Or if you have to add any type of descaler or any treatment to your water
water
if it's
conditioning.
hard water conditioning, because you're going to want to test your water before closing your system to see if you need to put any kind of additives into your system.
So we've got a system. We've piped it with all the accessories. We've either used copper. We're pressing it on. We're not brazing. We can solder it. We use the rehaul piping with the rehaul tool.
Before we move to the next step, I just had a question, Gary. When it comes to the air elimination, I know you kind of touched on it, where depending on if your HBC or indoor coil is at the higher point, that's where we want to do our air elimination. Now, do we offer a special type of air eliminator? Can we just put a T in and throw one of those quarter-inch high vents?
We're highly recommending using the Caleffi air separator that we has been engineered out for this system. Maybe Zack could answer, if people are going to try to use any kind of third-party products in our installation, what does that do? And
yeah, I think you kind of nailed it on the head there. We want to use what's recommended by the factory and the team that designed it. Going forward in the future, once we get more projects installed and get a much better feel for what we can use from third parties, it's a possibility. But for right now, we want to maintain using what we know works.
Getting back to trying to install this in my head here, the system's all piped. We're all ready to go before we fill it with water. Is there any pressurization or any testing that we have to do or should do?
Strictly on the water side, we're suggesting that you pressurize your entire system or your individual runs to the indoor unit at 43 psi.
We can use just compressed air for that.
So that's compressed air,
right?
From your air compressor.
Yeah, don't have to use nitrogen. It's just air.
24 hours, pump it in. It's very easy to do it in that manner. And that's 43 is the magic number. If you exceed that, if you go into the 50s, the high 50s and 60s, you could have some of the check valves that are internal inside of the HBC will open up. And I know from experience that did happen. So you hear like a pop, it opens up, and then it closes back down.
Is that a pressure relief?
It's like a pressure relief valve. It's internal to the unit.
Yeah, because every hydraulic system has to have a pressure relief of some kind.
So also going back to the air separators that you're installing at your highest point, whether it be at your HBC or the indoor unit, the kit comes with a plug for the bottom, and also it comes with two separate caps that are on there. So what we have is the cap that comes with the unit that can be tightened down for when you're doing your pressurization. But then you're going to change all those caps out, and it's a hydroscopic air cap, as they call it. That's the cap that once the system is ready for use, you would put that cap on there. You'd have to change that cap out.
All right.
That all comes within the kit.
All right, so let's talk about air elimination, because anybody who does hydronics knows there's two kinds in my mind, two kinds of air elimination. One is when the system is already up and running and it's been purged of air. The air eliminators that we're talking about so far, that's after that happens, right? It's to take out any small amounts of air that come into the system later. So is there an air purging process or method that we need to do as part of the startup?
Yes, there is. The water side of it, there's two procedures that need to take place during the startup. So the first is the debris removal operation. And this is all done after the system's installed, all your piping is completed, your electrical, you're ready to go.
So that should be a one-time process at startup. Debris, that's something new to me.
Yep. Yeah, it's all debris, yeah. So they did find, and here we're going to go back to our City Multi standard procedures, is that when we're starting up our systems, we're going to plug maintenance tool in. You're going to do everything the same. You're going to make sure that all the addressing, the ports line up, all that is still the same, except when you pull the screen up, when it's HVRF, there's two boxes, and the box is going to say air debris removal, and it's going to say incomplete. And once the system is done, the debris removal, it will change to completed. And maybe somebody can correct me if I'm wrong, but that's going to be part of the warranty, is when they review the maintenance tool files, they're going to be able to see if that was taking place or not, if you had the debris removal side of it. Yeah.
Oh, well, that's interesting. We are working on training. Gary, you are actually working on putting together some training for this. We'll be having, I'm sure, some videos. We'll be having maybe a couple of live webinars. I'm not sure what we're going to do yet, but there will definitely be a class that you'll be able to attend for this, so we can actually walk through that whole process.
But we're not done yet, because once we're done the debris removal operation, we now have to switch gears and change it to the air removal operation, which pretty much is almost the same as when we're doing the debris, but there's a couple other different things that we're going to change some different dip switches on there. And it's going to go through its same process. It's going to go through air 1, air 2, air 3. But once it reaches the air 4, that's when the outdoor unit is going to turn on.
Oh, wow.
The outdoor unit is automatically going to turn on, and it's going to turn all the indoor units to heating mode, and it's going to run out the rest of its air removal operation in heating.
We need to know this if we're going to be doing a startup in the summertime. We need to tell, if the building's occupied, we need to make sure everybody knows. It's going to get a little warm, but then the good news is we'll be able to cool it off.
Yep. Yeah. So, and that's a secondary part of the startup process, is getting the air. It's getting any kind of air that's left over in the system. It's getting it out. And it's also, you're still going to be using and utilizing those air valves on the indoor units and on the HBCs to get the air moving out. And then there's a process of turning off the dip switches and closing them down for the final input.
Very informative. I've certainly learned something. So Gary and Bryn have had the benefit of actually putting this in their respective training centers. Zack, have you must have been to Manhattan and seen that system there? Have you seen any others installed?
Yeah, we did a test project or pilot site up in Boston that was installed, say, 3 years ago or so. They liked it so much, they're looking to add another system to another dormitory building at the site.
Oh, beautiful.
And this is a very new technology to the U.S. We're the only manufacturer that makes this type of system. There's not many projects out there yet. We're anticipating that as this refrigerant change comes up, engineers, owners, architects are going to start to pay more attention to it. And luckily for us, we have a nice, easy button that we can use.
Yeah, that was one thing I was going to mention is we talked in the beginning about, the change in refrigerant and why this is, kind of our answer. But this is already available. We have this in the 410A. We already have HVRF available for installation.
Yeah, I guess one thing we haven't really touched on yet is how the system looks like on the design side of it. It's virtually the same exact design principles that you're going to be looking at for a regular VRF system. Same piping length, same indoor unit styles. Your controls are not any different at all. And the idea here is not we're trying to replace VRF systems. We just have another option in case you run into RCL issues.
Anything else to add? I'm sorry, Bryn.
The only thing I was going to say is, in theory, I like this as well because if we do go through any refrigerant changes in the future, we're not having to replace coils again. We can leave those water coils. We might be able to update the HBC in our outdoor and maintain this just the new refrigerant under new guidelines and remain with the hydronic coils.
Yeah, possibly. Yeah, that still remains to be seen, but I don't see why it wouldn't be the case. Gary, anything else to add?
Not really.
Zack, we'll give you the last word on this topic. Anything else to add?
I guess last thing I would just say is that, the future of, VRF system heat pumps in general is refrigerant to water. If you went to the AHRI show this year, I'm sure you saw tons of equipment from tons of different manufacturers that are all refrigerant to water. And this is one of the first steps, and there's more to come.
All right. Excellent. Exciting. Awesome. Thank you both.
Let's go get some pizza.
For joining us. Yes. So,
yeah.
All right. So speaking of that, Zack, I might have to come down to New Haven to discuss that RCO a little more in detail. So what's the best place in New Haven? What's your favorite place?
My favorite's Modern Pizza.
Modern Pizza.
Easily located off of I-91.
Okay.
That's how I found it. Yeah.
And hey, while we're down there, we can stop off at Hotel Marcel and check out the Heat 2.0 system.
That's right.
Awesome.
That's a whole nother podcast. I think, did we do a Heat 2.0?
Oh, yeah.
Oh, yeah, we did. Yeah. Memory's the second thing we do. All right, guys, thank you. Take care.
Take care.